Hello dear students, just I am continuing the chapter Introduction to 3D Geometry 12.2 exercise. Just in the previous class we have seen that the distance between 2 points is given by what? PQ equals to, just we can write like distance between 2 points is equal what? x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is distance between 2 points. Here P x1, y1, z1 and Q x2, y2, z2. Okay, distance between P and Q. Distance between P and Q is this. Okay, so this was our formula for distance between 2 points. By using this formula, we can solve the questions just like show that the question 2. So that the points, 3 points are given are collinear. Collinearity can be proved by using different methods. Here, just we know the distance between 2 points. Suppose here the 2 points, if one point is A, another point is B, another point is C. Collinear means lie in a single line. There are 4 methods for solving, for proving collinearity of 3 points in a plane. Okay, or also in the space. Just 2 lines always lie in a line, we know. If these 2 distance and this distance, that is AB plus BC equals to AC, that is what? That means what? This B lie on this, means if we can write like this, AB plus BC equals to AC. B are eliminated just like this. That is 3 distance, AB, BC, CA. Just find the distance. Just if we see that's just like triangle A, B, C. Just find the value of this plus and this and this. If sum of this is equals to this, that means what? 3 lines, triangles having area 0. So that is AB plus BC equals to AC. That means what? This distance and this distance plus is equals to this distance. That means all line points B will lie here, collinear. So this is one technique. Okay, and also by using coordinates we can also prove the collinearity of 3 points. Externally and internally division by using. Okay, so here just for proving collinearity, AB plus BC equals to CA. If we can show, then the points will be collinear. So here the question second solution. Question second. Okay, so points are given what? Given points are A, B and C. What are given points? Minus 2, 3, 5, minus 2, 3, 5, and 1, 2, 3, 1, 2, 3, and 7, 0, minus 1, 7, 0, minus 1. These are the 3 points. Just we have to show that these points are collinear. Okay, the given points are this. We have by distance formula, AB equals to, just using this formula, AB equals to AB 1 minus 2 square plus 2 minus 3 square plus 3 minus 5 square. Just using this formula for these 2 points, you can get the value. What? 3 square 9 plus 1 plus 4 equals to what? 14. BC AB equals to, okay, BC equals to, just find BC, same, 7 minus 1, 0 minus 2, 7 minus 1 square plus 0 minus 2 square plus minus 1 minus 3 square equals to what? 7 minus 1 is 6, 36, plus 4 plus 4 square, 16. Okay, so what is the value of this? Third is 40, 50, 56, root 56, 2 root 14, 2 root 14 you can write, and also another value AC or CA, just you can write AC or CA. The AC equals to these 2 points, minus 7 minus 2 square plus 0 minus 3 square plus minus 1 minus 5 square. This is equals to what? Just write 7 plus 2, 9, 81 plus 9 plus 36. 9 plus 36. So this is equals to what? We see this is equals to 126 root 14. 126 equals to 3 root 14. Okay, so AB, BC, AC. Just we find only distance between points. We see that here we see that AB plus BC equals to 14 plus 2 root 14 equals to 3 root 14, that is AC. AB plus BC equals to AC, implies AB plus BC equals to AC, which implies A, B, C are collinear. Clear? So this is by using distance formula for proving 3 given points are collinear. Okay, just if we can show like this. Okay, now next question. Verify the following points are vertices of an isosceles triangle. First question. Second, right angle triangle. Third is vertices of a parallelogram. So just by using distance formula we can show, verify. Okay, the isosceles triangle means just find the side of the triangle by taking in given points in order A, B, B, C, C, A. Okay, and if two are equal and sum of 2 is not equal the third, because sum of 2 is equal the third distance, that means collinearity. If not collinear and two sides are equal, not collinear, then they are making a triangle. So third question, third first, for isosceles triangle. For isosceles triangle here, given points are what? A is given 0, 7 minus 10, 0, 7 minus 10, B is what? 1, 6 minus 6, 1, 6 minus 6, and C is what? 4, 9 minus 6, 4, 9 minus 6. So these are the given 3 points. Just we have to show these are the vertices of a isosceles triangle. Isosceles triangle means just if A, B, C, then A, B, C, A, B, B, C, and C. Just we have to find the value. If two are equal and third is different, and also sum of any two side is not equal to third side, then we can say that these 3 points are the vertices of a isosceles triangle here. So here we see that by distance formula, AB equals to and BC equals to and CA equals to. What are the value? Just find the value. AB 1 minus 0, 1 square plus 1 minus 0 square plus 6 minus 7 square plus minus 6 minus plus 10 square, and here BC 4 minus 1 square plus 9 minus 6 square plus minus 6 minus plus square. Here AC CA just you can write 0 minus 4 square plus 7 minus 9 square plus minus 10 minus 6 square minus 10 minus 1 plus 6 square just equals to what is the value of this equals of this equals of this equals just is 1 plus minus 1 square 1 1 1 2 and this 4 square 16 root 18, this is root 18 and this is what root 18 and again root 18 and root 36. Root 18 here also 3 square 0 square root 18 and here root 36. Just you can see that 36 16 420 30 36 okay. So this is the value. Okay, this can be written as 3 root 2 and just 36 means 6. Okay. Here we see that what two sides are equal, but sum of two sides, any two side is not equals to the third side, and also AB equals to BC and not equals to CA implies ABC are vertices of and isocel. Partition of isocels. Isocellus. Okay. Isocellus triangle. Clear? So here two sides are equal. Isocel triangle. Because sum of any two sides is not equal to third side, that is make a triangle, and so this is an isocel triangle. Vertices of an isocel triangle. Third question is what? Second point is right angle triangle. Just second point is right angle triangle. Here we know what are the points given. The second question, just we can see that we can find the value of ABC are given what? 0, 7, 10, 0, 7, 10 and minus 1, 6, 6, minus 1, 6, 6 and minus 4, 9, 6, minus 4, 9, 6. These are the point, and we have to show that these are the vertices of a right angle triangle. Right angle triangle, you know the Pythagoras theorem. In a right angle triangle, Pythagoras theorem says square of one side is equal to sum of square of other two sides. Here just to find the value of AB, BC, CA. Okay, so AB, BC, CA, just you can find AB, BC, CA. Okay, so here AB equals to just right here AB minus 1 minus 0 1 square plus 6 minus 7 minus 1 square minus 1 square minus 1 minus 0 square 6 minus 7 minus 1 square plus 6 minus 10 minus 4 square is equals to. Similarly here what this 2 minus 4 minus 1 means minus 3 square plus 9 minus 6 3 square plus 6 minus 6 0 square equals to, and AC equals to what? Minus 4 minus 0 minus 4 0 4 square, and similarly 9 minus 7 9 minus 7 2 square plus 6 minus 4 square equals to. So here what? 16, 17, 18, root 18. Okay, 3 root 2. And here 9, 9, 18 square, root 18, 3 root 2. And also here, just we see that what? 16 plus 16, 32, 36, root of 36 is equals to 6. We see that. Here we see that AB square plus BC square equals to 3 root 2 square plus 3 root 2 square plus equals to 9. 18 plus 18 equals to 36 equals to 6 square equals to CA square. Implies AB square plus BC square equals to CA square, implies by Pythagoras theorem, with Pythagoras the square of one side is equal to the sum of the square of other two sides. So by Pythagoras theorem, A, B, C are vertices of a right angle triangle. Vertex of a right angle triangle. And for parallelogram, just you can prove it. For parallelogram, just we know that in the parallelogram, the opposite sides are, length of opposite sides are equal. So here, take points in order. By taking points in order, we have to find the value of length of the sides. Okay, so here points are given, just see. Third option, part third. By taking in order given points are A, B, C, D. What are the points? -1 to 1, -1 to 1, and 1 - 2 5, 1 - 2 5. Okay, ABCD are the notation. 4 - 7 8, 4 - 7 8, and 2 - 3 4, 2 - 3 4. These are the points taken in order. Taking in order, given points of this. Taking in order means, suppose this is A, this is B, this is C, this is D. A, B, C, D. Taking in order. First A, then B, then C, then D. Just we have to find the value of, is it quadrilateral? No. If A, B, C, D are equal and B, C, D are equal, then we can say this is a parallelogram. Okay. So, order, when points are this, and we have by distance formula. By distance formula. AB equals to BC equals to AB, BC. Just find by using distance formula. Similarly, first point AB, where this minus this, 1 - 1, 1 minus -1 square plus -2 square plus 5 - 1 square equals to what? Root over 2 square means 4 plus 16 plus 16, root 36 equals to 6. So first distance is 6. Similarly, BC, CA, CD, DA. What are the value? Just you can find BC, CD, DA. BC, CD, DA. BC, what is BC? Root 43. Root 43. And CD is given 6. And DA is also 43. Just see. Just use the distance formula. You can find all the values. So here we see that. In order AB and CD. AB and CD. AB equals to CD 6 and BC equals to DA equals to 43. Okay, this. That means length of opposite sides are equal in a quadrilateral. So here opposite sides of a quadrilateral, opposite side, okay, opposite sides of a quadrilateral, okay, ABCD, opposite sides, which quadrilateral whose vertices are taken in order, are equal, taken in order. Opposite sides of a quadrilateral ABCD whose vertices are taken in order are equal implies ABCD is a parallel. Okay, so this is good. Now, question 4. Find the equation of the set of points which are equidistant from 2 points. Means just we have to find the equation that is satisfied by a point. It is equation set of points, means in other words we can say that the equation of or locus, path of a point whose distance from 2 points are always equal. Okay, so here let Pxyz be the point whose distance from A, given points, 2 points are given, the points whose distance from these 2 points are always same. That is, if P be the point, then PA and PB equals to same. A is 1 to 3, and B, let P be the point whose distance from A and B be 3 to minus 1. Distance from A and B are equidistance, are equal. With the point whose distance from these are equal. That is what? PA equals to PB. So we can write what? Distance formula by using distance formula. PA. P means xyz, A means 1 to 3. So 1 minus x square plus 2 minus y square plus 3 minus z square equals to PB. PB means this 3 minus x square plus 2 minus y square plus minus 1 minus z square. Okay. So squaring on both sides, just we can write, remove the square. Okay. So squaring on both sides and just breaking the square. So 1 minus 2x plus x square, 4 minus 4y plus y square, 9 minus 6z plus z square equals to, just right side, 9 minus 6x plus x square plus 4 minus 4 y square, just plus minus plus, so 1 plus 2z plus z square Now from both sides just cancel out and just solving. After solving you can see that value is very simple. Okay, but just subtract x square, y square, z square are cancelled, and also constant terms can be added. Just you can see that we can get the value like x minus 2z equals to 0. X minus 2z equals to 0. Just after solving we can get. Okay. The square term will cancel out and the remaining terms are adjusting like this. Here y terms what? Minus 4y. Here also 4 minus 4y plus y square plus y square plus 1. Minus 4 cancel, and so y square cancel, and x square z square cancel, and all things are cancelled. Just you can get this result x equals to 2z. This is the equation. Okay, which is the required equation. Which is required equation. Which is required equation. X equals to 2z. X equals to 2z. X minus 2z equals to 0. So just you can use condition. Here question 5. 5 is given that find the equation of the set of points, sum of whose distance from the points is equals to 10. Okay. Question 5. So you can do it. Just do it from yourself. Okay. Here 2 times you have to square. Okay. Just question 5. Let P, X, Y, Z be the point such that PA square PA plus PB square PA plus PB equals to 10. This is given. Okay, PA plus PB equals to 10. Where AB, where A is given what and B, where A is given 400, B is given minus 400. 400 and B is given minus 400. So very simple. Points are given 400 and minus 400 equals to 10. Just we have to find the equation of the set of points, arbitrary points P, X, Y. Just use this relation. So from here we see that distance formula using is very simple. But just squaring on both sides and we can get like this. PA plus PB square is equals to 100 square. So here what? PA square plus PB square PA square into PB square of, just not by taking like this, just take PA equals to 10 minus PB, transfer and then square it. PA square equals to 10 minus PB square. We can get PA square. Square means without root, we can write formula. Here 10 square means 100, minus 2 into 10 means 20 PB plus PB square. Just use the point. PA square means PA. PA means what? 4 minus x square plus 0 minus y square 0 minus y square, 0 minus z square equals to 100 minus 20 root over PB. PB means minus 4 minus x square plus 0 minus y square, 0 minus z square. This PB square, also this thing is there. PB square, here we can write what PB square? Just this, minus 4 minus x square plus 0 minus y square plus 0 minus z square. Okay, now just this quantity here minus this and this and this are cancelled out. Okay, and transferring here 4 minus x square, transferring here minus 4 plus square. Just minus both, so minus 1 plus 4 plus x plus minus 4 plus x square. These are cancelled out, equals to minus 100 on the left hand side equals to minus 20 root over this 4 plus x square plus y square plus z square. Okay, now just solve it here. 4 square x square, 4 square x square, cancel out. Minus 8x minus 8x minus 16x minus 100 equals to minus 20 root over 16 plus 8x plus x square plus y square plus z square. Now just squaring on both sides. Squaring both sides and simplifying. We can get squaring both sides and simplifying, we can get result as 25 plus 4x, just 25 divided by 4. Okay, 24x plus 25 here 5, I think 5 root of what this. We can get 9x square plus 25y square, 9x square plus 25y square plus 25z square minus 2 to 5 is equals to 0. Clear? 9x square plus 25y square plus 25z square minus 2 to 5 equals to 0, which is required equation. Just simplify. How? Divide by minus 4 first and then squaring both sides and simplifying, we can get this as a result. Okay, so this is the complete of the exercise 12.2. Okay. Now, just the next topic, I will discuss about next topic. So, by distance formula, we can prove relation, prove the whether the given points are vertices of triangle, square, parallelogram or not, just finding the distance and giving the logic. Okay, and also we can find the equation of a arbitrary point which will move in such a way that its distance from some points are given with some condition. Okay, so just use the distance formula. Now section formula. Section formula. Okay, so section formula. Section formula. Just in the previous class, we have seen that the section formula in two-dimensional. How we use formula? Suppose we are having point x1, y1 in two dimension and q x2, y2. 2 points in two dimensional. We know that section formula means what? In between, if R is a point, x and y, its coordinate. If it divides this distance from this P to Q, M and N ratio, internally, if internally, then x equals to what? Just M plus N, and y equals to M plus N. And how can we write the formula? Here, just M x M x2 plus N x1. Similarly, y M y2 plus N y1. So x, y are given by this, where R divides the point. This is in two-dimensional plane. Similar formula just we can use for 3D space point, that is points having triplet as a coordinate. Just z is equals to similarly m plus n, m into z2 plus n into z1. Here will be what? Z, here Z2, here Z1. R is the point x, y, z. Internally, these are the values. Coordinate of R is written like this. Just we can use this formula. Okay, because proof is very simple. Just we can draw the diagram just like this. Suppose this is our 3D diagram. For 3D diagram, just we can draw like this. This is x-axis, this is y-axis, this is z-axis, this is origin. So here P is this and Q is this. Q point, here P point. Okay, so just draw the perpendicular in this plane, lower plane. Just you can see that. Just draw perpendicular in lower plane, and here also draw perpendicular in here. So this is the plane. Okay, now if this is, because we are writing here drawing just like this parallel, so parallel to this line PQLM, this line is on the plane, this is on the XY plane line, and this is PQ. Okay, in between, suppose internally there is a point, R. Its coordinate we have to find. Its coordinate is what? x1, y1, z1. Its coordinate is x2, y2, z2. And its coordinate is x, y, z. Okay? Now we have to find x, y, z in terms of x1, y, and z1, x2, y2, z2, where it divides mn ratio. Okay. Now, just we can draw parallel to this line. This is L, suppose. Okay, just we can draw line from here. Just we draw also a point here. All this foot of the perpendicular line will lie on same line. Okay. Now draw here parallel to this. Parallel to LM, this line. Okay, this is PQ. This is PQ. X2, Y2, Z2. This type. Now in this triangle, in this two triangle, we can find, because these two triangles are similar. By similarity of this triangle, we can find the value of, just by using similarity, we can use m by n equals to, because both triangles are similar, so this by this equals to this by this equals to this by this, we can write. Okay, so here this is the value what of in this direction parallel to z axis. So here this value is z1, this value is z2, so this value is z, so this value is what, z minus z1, so this is z minus z1, or this is what, this value is z2 minus this value is, this is z1, sorry, z. So these two are similar. Just you can write P here. Just here P, this is P, this is Q, suppose R, suppose S, P. Now PTR, triangle PTR and triangle RSQ, RSQ are, these two triangles are similar. Since these two triangles are similar, these two triangles are similar, then you can use this by this ratio, m by n. M by n is equals to z minus tp by qs, that is z minus z1 upon z2 minus z. From here you can get the value of z is equals to m z2 minus n plus m plus n. Just you can get this relation. Similarly, by drawing perpendicular P from PRQ in the other plane, just in XY plane, just in XZ plane, also in YZ plane, we can get these two values. So, formula is what? Internal division. Internal division in ratio m ratio n. Internal division in m ratio n Giving formula what? M plus n, m plus n, m plus n, m x2 plus n x1, m y2 plus n y1, m z2 plus n z1. This internal division in ratio. And external, if we take this point external side, that is either here or either here, then just n will be negative. So external division in ratio m ratio n will give the formula what? Just negative sign in place of m minus n, and here m x2 minus n x1, m y2 minus n y1, and m z2 minus n z1. Okay. Coordinate of point of internal division and external division. These are the formula. Okay. That is, if we are having point to point P and Q, and there is a point R, external division 2 ratio 1, 3 ratio 4, and etc. M ratio n, internal division, then you can use its coordinate. In terms of P and coordinate of P and Q is given by like this. If P and Q, here P, here Q, and R is here, external. So this is PR and this is QR. So this is M, this is N. And also if here is R, then this is N, this is N. So in the case of internal, external division, just you use minus N in place of N. So this is the external division. So this section formula is very, very important for find. By using section formula, we can also prove the collinearity of 2 points. Just suppose there is given 2 points. Okay, one point, another point. Just find its, if third point is on this line or not. If we find third point as a division point and comparing its one of the coordinate with given point as a third point, and by getting the value k, and this k will give same value as other two coordinate from this formula, then we can say that C is lying on this line because internally or externally divided. Here also, for finding the ratio m by n, we use let k equals to m by n. That is k by 1 equals to m by n. So m by n equals to, if we say that k, that is k ratio 1, we can suppose. So we can use here k plus 1. Here k 1, k plus 1, k 1, k plus 1, k 1, k plus 1, k 1. That means just divide by it by n. So m by n, here 1, 1, 1, 1, 1, 1, m by n, m by n, m by n. So it can be written as also k plus 1, k 1, k plus 1, k 1, k plus 1, k 1, k plus 1. Just for finding the ratio, we take k ratio and find the value of k. if getting positive value, then internal division. If getting negative value of k, then external division. And ratio is given by the value of k. Okay. So this is the section formula for finding ratios, coordinates of points. So take questions from exercise 12.3. Solution. First question. Just using this section formula, we can solve questions of exercise 2.3. Here only it is given that find the coordinates of the point which divides. Coordinates of the point which divides internally and externally. Here points is given that formula. First question. Internally division in 2:1. In 2:1. Okay, 2:1. 2:3, sorry, 2:3. Okay, in ratio 2:3. Of segment joined segment joining A. First point is -2, 3, 5, -2, 3, 5, and B is 1, -4, 6. 1, -4, 6. Okay. So segment of line segment. That is point. Internal division point, we can say also. Okay. R is what? Just using this formula. Mn. So 2 plus 3. 2 plus 3. 2 plus 3. 2 into x2. x1, y1, x2, x3, y3. Sorry, x1, y1, z1, x2, y2, z2. This is x1, y1, z1. x2, y2, z2. So 2 into x2. 2 into x2. 2 into 1 plus 3 into x1 minus 2 into 3. Here 2 into y2. 2 into minus 4 plus 3 into 3. Here 2 into z2. 6 plus 3 into minus 5. So just we see that R as what? Internal division. Internally divide what? Just solve it. 2 minus 6 minus 4 by 5 minus 4 by 5, and here what? 9 minus 8, 1 by 5, and here 15 plus 27 by 5, 27 by 5. So this is the division point. So you can write the coordinate of internal division point in ratio 2:3 of line segment is this. Similarly, second question. Second part is what? Externally division. Externally division. In 2:3. Just take negative sign. Okay, so r, just take negative sign. 2 minus 3, 2 into this 1 minus 2 into 3, 2 minus 3, 2 minus 3, and here 2 into minus 4, minus 3 into 3, just 2 into 6, minus 3 into 5. Just you can see what is the coordinate. What will be the coordinate? Just here minus sign is there. So 2 minus so plus 6, 6 to 8, 8 minus 8, minus 8. Just solve it. Okay, you can get minus 8, 17, 3. Minus 8, 17 and 3. So this is the external division point. For external, just this formula, use this formula. Just internal, just use this formula. For finding ratio, just we use k ratio 1. Then find the value of k. Okay, so completed. Just you have to complete all the examples also. Okay, and write in your homework copy and send me 2-3 solution of 2-3 questions for your attendance. Okay, just I will continue in the next class miscellaneous exercise and remaining questions from 12.3. Okay.